Hello everyone, and welcome to Deceptive Rainbow Arrows tutorial. On this module there are 8 colored buttons. One of them is black, so this is definitely not normal rainbow arrows. It will flash a sequence of 6 combinations. It's either 1 or 5 buttons flashing, and the sequence ends when the middle screen flashes. So let's write down the initial display, 53, it's flashing with green. And let's write down the sequence, but if the button is flashing alone, we will just write it down, the color. If 5 colors are going to flash, we will write down the 6th color, odd one out, and note down that it is inverted. So white and black arrows will never flash, so we disregard them for this step. So let's start. It starts with normal purple, single purple. Yep. Next one is, I think it's orange, everything except orange, which means orange is inverted. Next one is purple again, normal. Next one is orange inverted again. Then blue inverted. Yep, it's blue inverted. And the last one is on this side, I believe. Yep, it's going to be orange inverted. Now, in this module, you will need to do 3 queries. After each one of them, get 3 responses in total, and then submit an answer. Each query and answer will contain two arrows to submit, or rather use. And one more thing, base display right now, it will always be in base 8, but we will need that later. So right now let's go to the first query step. First of all, we will need the serial number, and we will split it into 3 pairs, like this. Then we convert each letter into its alphanumerical position. And in each pair we add together numbers. And then modulo each one by 8. Call these numbers z, y, and x in this order. Now we're going to this table. Z is 1, so we're going to use these colors as representations of these octal digits. So if we have an even amount of batteries, which we don't, so otherwise, first color is going to be represented by x value, which is 5, so it's going to be black. And the second one will be represented by y, which is 7, which is purple. If we had even number of batteries, we would swap them around, so it would be purple and then black. To query the pair, simply press them in order, like purple, and click the screen. And like in 2 bits, you cannot interact with the module while it's waiting or showing the response number. If you do so, you will strike and you will be just struck and sent to the initial state. Anyway, first response is 33, and we don't need this anymore. Go to the second query. For this one, we will need 2 binary strings with the length of 6 bits. First one is obtained from this flash sequence. If the flash is normal, the bit is 0. If the flash is inverted, the bit is 1. It's going to be 0, 1, 0, 1, 1. Second string is obtained from first response from this table. So 3 is going to be 0, 1, 1 and 0, 1, 1 again. Then we're going to apply XOR operation to top and bottom digits to each pair. So it's going to be 0, 0, 1, 0, 0. Now we're going to take second, fourth, and sixth digits, bits to be precise, and convert them into the number. Then do the same with first, third, and fifth digits. Convert them to number 2. Take those numbers in row. First is row, second is column. Gives us the number 45, which is translated into red and black. And this is our second query. Our second response is 51. Now, this part might seem too complicated, but if you know how black hole works, this is not actually going to be that hard. There are a few exceptions from black hole. So, to find the starting position, we're going to take second response. But unlike black hole, first digit represents row, second represents column as well, starting from 0. So this is 1, 2, 3, 4, 5, and the column 1, which is this one, which gives us the starting position of this cell. We're going to face the same direction as the white button, and unlike black hole, we will not just rotate 45 degrees each time. We need to know the color of the display when it's flashed, which is green. We count the number of clockwise spaces. We'll go from white to green, which is 3. And like in black hole, instead of 1, unlike black hole, instead of 1, we're going to go 3 times clockwise. So right now we're facing here, so I'm going 1, 2, 3. So we're facing here, we're going 1, 2, 3. First, let's write down the sequence: 5, then 6, 2, then 4, 5, 5. We're face 4. Okay, wrapping around. We're facing here right now. 1, 2, 3, 3, 1, 0. We need to take 4 numbers like that and add together each set. 8, and then modulo each one by 8. Now we need to apply XOR to the first pair of digits and then the second pair. 5 is using again this table. 5 is going to 101, 0, 0, 0, 0. XORing gives us exactly 101, which is 5. 6 is 110, 0, 0, 0, 0. XORing gives us 110, which is 6. We'll go to this table. 5 as the row, 6 as the column, gives us number 35, which is translated into green and black. This is our third response. Third query. Our third response, however, is 0, 4. Now, the submission part is probably the longest one, and we're going to start from the ports, which we don't actually have. So the rule says us to observe every port type with the most occurrences. Right now we have no ports at all, so all types are actually tied with the most occurrences. In this case, if we have 4 or more tied ports, in our case we have 6, we would omit first, third and fifth flashes in this initial sequence. So we get rid of purple, this purple, and this blue. If we, for example, had something like PS, RCA, PS, serial, DVI, and DVI, we would have 2 PSs, 2 RCAs, 2 DVIs, 1 serial, and 0 of everything else. So we would have RCAs, PS, and DVIs. PS, RCA, DVI. In this, what a coincidence! In this case, we would have to use the table if we had only 1, 2, or 3 tied port types, and use the position that the table tells us to omit. But in our case, it's not what we do, where the positions here are actually the same somehow. What a lucky man. Okay, now we're going to create. No, first of all, we're going to change this number to base 10, because right now they're in base 8. So let's do that. This is going to be 43, 27, 41. This stays the same. Now we need to create a new variable. Let's call it current, and it starts with the initial value, it's 43, base 10 of course. Now for each color in this sequence, surprisingly only orange, we are going to apply the function of the color. So we're going to take function of orange. In the case when the flash is inverted, we're going to solve the equation for x and use the function of x as the current value. For one, oh, by the way, the A is the list of responses with the index starting from 0, so let's rename this to A0, A1, A1, and A2. So A1 is 41, adding them together gives us 84, but we need to keep the calculated value within 0 and 63, so we're going to subtract 64, which will give us 20. This is our new current value. Next is going to be orange inverted again. So in the case, for example, when the color is not inverted, we would actually solve for function of x and use x as the current value. But in this case, all of our flashes are inverted, so we'll solve all of our equations for x. So function of x is going to be the current value, 20, plus a1 going to be 41, plus 20 is 61, which is in the range we need, so the new current value is 61. And then we say the same function, current value is 61, a1 is 41, which gives us 102. Keep in the range, we subtract 64, which gives us 38. Since we're done with all the flashes, it's our final value. But right now, it's in base 10. We need to convert it back to base 8. So let's do that. It's going to be 4, 6. But before we do anything else, I need to tell about something else. So n is the position of the function right now we're using in this list. So for example, if we are using the function for this color, the n would be 2, because it starts with 0, it's 0 indexed. If we're using the function for this flash, it's going to be 0, for this flash 1, and for this flash 2. But since we didn't use any, we didn't have to face these problems. Maximum of A is the highest value of these three, of course. Minimum is the lowest value. Sum of A is the sum of these three values. And when you divide it by 3, you will most likely get some decimals remained. Immediately write it down before doing any further calculations. And one more thing. So this and these functions can be simplified. So for example, here we can just subtract x from both sides. Here we can subtract 3 purples of x from both sides and add x to both sides. This is what I always do, and I have no idea why the manual is like that. It should have been simplified in the first place. But since our current value is 46, we're going to use this table, 4 for rows, 6 for columns, and translate 66, which we got, to white, which is going to be our final answer. To submit an answer, click the screen first, then input those 2 arrows and click the screen again. And this is how you solve this module. Thank you for watching, and I hope you will never run in the problems I had while learning this module. Bye.